Once again, we have another problem that deals with hybridization. And this question reads, what is the hybridization for the carbon and nitrogen atoms in the following molecules? So we have 3 molecules here. We've got 1, 2, and 3. And so what we're going to do is we're going to come up with the hybridization of each one of the nitrogens and carbons. So to start out with, let's look at, so this will be molecule A, we'll call this molecule B, and over here will be molecule C. Okay? Let's look at this nitrogen here. Now the nitrogen here has how many things bonded to it? Well, it's going to have 1, or how many electron domains does the nitrogen have? Well, it has 1, 2, 3, 4. So it's got 4 things bonded to it. Therefore, the electron pair domain or electron pair geometry is going to be tetrahedral. Remember, if it's tetrahedral, then the hybridization of that nitrogen is going to be sp3. That means there's 4 hybrid orbitals, 1s and 3p, so you have 4 hybrid orbitals in that's going to be the hybridization for this nitrogen. Likewise, we see the exact same thing with this nitrogen. The 2 nitrogens are essentially the exact same, and so this is going to be sp3. Now let's look at the carbon. If we look at the carbon atom, now I forgot the lone pair on the oxygens, I'm sorry about that, but we're only looking at the carbon. The carbon has 3 things bonded to it, 2 nitrogens and an oxygen. And we can see that the shape of this, in essence, is kind of trigonal. It's going to be planar because there aren't any lone pairs coming off the carbon. And so since this is trigonal planar, this carbon is going to be sp2. Now, we can notice it because of the geometry, because the carbon is going to be trigonal planar. Hopefully you can kind of see the triangle form there. Or we can notice that an sp2 is going to have 3 hybrid orbitals, and there's 1, 2, 3 things bonded to that carbon. We jump down to this one, down to B. We can look at this carbon, and it has 3 hydrogens bonded to it, as well as a carbon. So this carbon, another way we could write this, if we got rid of these 3 hydrogens, is we could write this now as though it were to have 3 hydrogens that way. It's the same thing. We can look at this and we can see that there are 4 things bonded to this carbon, and therefore it's going to be tetrahedral. If it's tetrahedral, that means that the geometry is going to be sp3. We can also notice that sp3 means that there's going to be 4 hybrid orbitals, 1s and 3p's, and so that's going to give us 4, and there's 1, 2, 3, 4 things bonded to the carbon. We move over to this carbon, we see there's only 3 things bonded to it, a carbon, which is going to be double bond, and then a single bond to the hydrogen. Because there's only 3 things bonded to this carbon, that means there's only going to be 3 hybrid orbitals, and that means this will be sp2. We can also notice that the geometry of that one is going to be trigonal planar. Once again, that's going to tell us that the geometry of that carbon is sp2. This carbon is going to be the exact same. We can see that this carbon has, in essence, 3 things bonded to it, a carbon, and a hydrogen. It's going to be trigonal planar, and so this is going to be sp2. Likewise, we look at this carbon, and it has 3 things bonded to it. It has a hydrogen, an oxygen, and another carbon. And this is going to be trigonal planar as well, and this carbon is going to be sp2 as well. And so all the carbons, with the exception of that carbon, are going to be sp2. We come over to this molecule, molecule C. We can look at the carbon here, and we see that it's going to be trigonal planar because it has 3 things bonded to it, a carbon, a hydrogen, and a hydrogen. And likewise, this carbon is going to be sp2. 3 things bonded to it, 3 hybrid orbitals, an s and 2 p's. That gives us 3. Likewise, this carbon is going to be sp2. It's got a carbon, and a hydrogen. It's got 3 entities bonded to it, and therefore it's going to be sp2 as well. Trigonal planar, trigonal planar. Now we get to this carbon. This carbon's a little different. This carbon has one carbon and a triple bond to the nitrogen. So the carbon here only has two things bonded to it. And because of that, there's only two things bonded to it, this carbon is going to be linear. And since it's linear, this happens to be sp. Now, sp tells us that there are two hybrid orbitals, so there's only going to be two things bonded to the carbon. And what's bonded to the carbon is going to be this carbon group and then the nitrogen as well too. Now we can look at the hybridization on the nitrogen and we can see that the hybridization is going to be the same as this carbon, because this is just going to be a lone pair such as that, right? We can put the lone electrons there. And what this nitrogen is going to be is it's going to be sp as well, because it only has two entities connected to the nitrogen. It's going to be triple bonded to a carbon, and it's going to contain one lone pair as well. And so this molecule is going to be linear, and thus the nitrogen atom is going to be sp hybridized as well. If you have any questions on these hybridizations, please ask.